Yes, it is. All right. So this particular part, we're going to review our exponent rules. So our exponent rules that we need to look at is we have the product rule. And the product means multiplication. So a product rule would be something like if I have negative 3x squared y, and I'm multiplying that by 6x cubed yz. So if you forget the product rule, if we can't remember if we add the exponents, we multiply the exponents, or we subtract the exponents, one way you can always do it is write it out. Now, I'm not going to ask that you write it out because this was something that was from, actually, I got the problem set from pre-algebra. So this is a pre-algebra skill. It's okay if you're still weak at it. Our goal is that we get it going better. So we basically are going to write, or we're going to multiply our two numbers. And so we get negative 18. How many x's do we have? We have 1, 2, 3, 4, 5. So we have 5 x's. I have 2 y's. And I have 1 z. So if we think about this, what did we do with those exponents? We added them. So the rule is if I have x to the m times x to the n, that's equal to x to the m plus n. Questions on that one? So that's the product rule. Anybody? We okay? All right. Next one we're going to do is the power rule. These are the two that we confuse the most. So if I have negative 7, oh, that's kind of big. Let's go with negative 2. Let's do a squared bc. And I'm going to raise that to the third power. And again, if you don't remember the power rule, that's okay. You can always go back and write it down and then see if you can remember it from there. So if I have 3 of these, I have negative 2, a squared bc, negative 2, a squared bc, negative 2, a squared bc. I have 3 of those. So this is really saying negative 2 to the third power. Negative 2 times negative 2 is 4, times negative 2 is negative 8. And then how many a squareds do I have? I have 3 of those. So how many a's do I have? Well, I have 1, 2, 3, 4, 5, 6. And really that's saying a squared raised to the third power, or 2 times 3, which gives me a to the 6th. And then I have b's. I have 1, 2, 3. So I have b cubed. And then I have 2 c's, c squared. So our rule for this one is x to the m raised to the n power is equal to x to the m times n. So you're multiplying those exponents. And remember, my exponent on my 2 is just a 1. 1 times 3 is 3. Questions on power rule? Anybody? Here's somebody. Anybody have a question?
How'd you get c squared if there's 3 c's?
Ah, you're right. I lost a c, didn't I? I didn't even box him. Yep, c cubed. You're awake. No. Yeah. Any other questions? No? All right. And our last rule is the quotient rule. And then we're going to look at some negative exponents. So our quotient rule, quotient means what? What's quotient mean?
Division.
Yeah, so we're going to be dividing. So division. So if I have 3a squared b c to the third divided by 12a b c. Now let's make it b to the fifth in the bottom there. So we can, like we have all the others, we could write this out. 3a b c c c. And then I have 12 A, B, 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 5 B's, C. And then I can cancel. And I cancel the 3 and the 12 the normal way. So 3 goes into 3 once, 3 goes into 12 4 times. So I end up with A C squared. I have 1A and 2 C's. And then I have 4, 1, 2, 3, 4 B's, and no C. So that would be my answer. So what did I really do with these exponents?
Subtract them.
them.
Yeah, how do I decide where they go? Because I ended up with a b to the fourth in the bottom. Anybody?
Wherever there's more of them?
Yeah, wherever there's more. So I had more b's in the bottom. So they're going to be down there, and I have only one b up top. So most of them are going to land there. So what would our rule be then if I have x to the m over x to the n, and we're going to say m is greater than n. So this, I have more up top. What would that equal? It's going to be x to the m minus n. Because I'm subtracting those exponents, and once I get that, it's going to be up top. Now, if I had x to the m over x to the n, and I had more in the bottom, and m is less than n, so more in the bottom, I'm going to have 1 over x to the m minus n. I think the rule for that is harder to write than it is just to say if you got more in the bottom, they stay in the bottom. If you got more in the top, they stay in the top, and I subtract the numbers. So, questions on quotient? All right. Now let's look at negative exponents. And I'm going to use a quotient as the example here. So let's do 3a to the negative second power, b, c to the fourth power, divided by 12, a to the fourth, b to the negative third, c to the fifth. Let's go with that. Now, there are two ways to think about this one. When I have students that struggle with negative exponents and they struggle with subtracting negative exponents, then my suggestion to them is this. If you have something that has a negative exponent, it's not happy with where it's sleeping. And what I mean by that is if these are bunk beds, this is the top bunk and this is the bottom bunk. Somebody that has a negative exponent, it's not that it's a negative number, so let's go ahead and throw a negative in there. So something that has a negative exponent is not happy with where it's sleeping. So the a to the negative second has a negative exponent. It's afraid of the top bunk. So as soon as it comes down to the bottom bunk, it's going to be happy. It's no longer feeling negative about the experience. It's come to the bottom bunk, and so it's happy. Now, I have my b to the negative third. It is in the bottom bunk, and it does not like to sleep in the bottom bunk. So it's going to move up. And once it moves up, then it will become a positive exponent. And so this, the negative 3, is only to the first power. And so you're going to go, that is happy where it is. So now I want you to go ahead and simplify this expression. That's a c. So that came down. I got b cubed, c to the fourth, a squared, a to the fourth, b to the negative third, and c to the fifth. Go ahead and simplify that one. All right. So let's look at this guy. Well, this is the product rule. So how many total b's would I have on the top? I'm going to cancel my 3 and my 12. All right. So how many total b's would I have on the top?
Got 7.
For b's?
Oh, no, 4.
Yeah. So I'd have b to the fourth. I'd still have now, so those I've put together. So those are out of the way. I have 4 c's and 5 c's. Where are my c's going to land? 4 minus 5 is negative 1. So that means c is going to have to be in the bottom. My 4's down there. And then I have a squared, and a to the fourth gives me how many a's? I've got 2 plus 4. Give me 6 a's. And that's it.
Doesn't matter where you put the negative sign.
Yeah, I was going to say that.
It doesn't. The only thing is typically we will write it with the numerator or we'll put it out front. We never really put it in the bottom.
Okay, thank you.
Any one of those. Good question, so. Anybody else? All right, then let's try. I'm going to pull one from our assignment today. Let's do... let's do this one. This is number 11. I gave you the odd answers so that you can check yourself, but this is number 11. I have 8x squared y to the fourth times 8 x to the negative third y to the negative second all over 6x y to the negative second times 2y x to the negative first. So go ahead and try that one on your own. And then we'll come back together and work through that. If you have no idea where to start and you are not super great about being able to subtract negatives and do that with 100% accuracy, then start with circling your people with negative exponents and moving bunks on your bed. All right, I'm going to do it 2 different ways here. So then that way, I'm going to do one way. I'm going to come over here and I'm just going to kind of rewrite my monstrous problem so that I'm going to do it the moving bunks way, and then I'll show you the other way. I don't care which way you go. So this guy is not happy, so he's going to come down. This guy is not happy, so he'll come down. I always circle them so then that way I can kind of follow where they're going. I'm going to rewrite. So 8x squared y to the 4th y squared 8 6x x cubed 2y. I think I lost him. I didn't put him up there, did I? And then I had a y squared come down. Whoa, that's kind of gnarly. Make sure I got it all. Squared 8x 6x x cubed 2y. Does anybody see where I lost anything? Those of you who did it this way. I think I got it all. All right, so now I'm going to do some smushing together here, I think, or canceling. It really doesn't matter how you go about doing this. You could put it together and then cancel, or you could just cancel. So like I see a y squared here and a y squared, see an x and an x, and I see a 2 and an 8. I have 2 x's here, I have 3 here, so that would leave me with 1 on the bottom. I have a y here, and I have 4 y's here, so I end up with 3 y's there. And then my 6 has a 2 in it, so I'm going to pull that out of that. Whoa, so that'd be what, 16y cubed over 3x. Yep, got the right answer. So that's one way. Any questions on what I did when I did it that way? Okay. Another way that some of you might like to do it better is maybe write your numbers out to the front. Get rid of those. Combine your x's. So if I have x squared times x to the -3rd, that gives me x to the -1st. That takes care of those. And then I have y to the 4th times y to the -2nd. 4 minus 2 is 2. And then in the bottom, I'm going to go ahead and write my numbers out to the front. I have x to the 1st and x to the -2nd, or I'm sorry, x to the -1st. So 1 minus 1 is 0, so those just cancel each other out. That just gives you 1. I have y to the -2nd and y, so -2 plus 1 is y to the -1st. And then I could do 2 minus -1, which is 3, so it would be up top. Or you could move bunks at that point. Boy, that looks a little bit easier, I think. And then I could cancel here. 2 goes into 8 4 times. 2 goes into 6, 3. 2 goes into 8, 4. So I end up with 16y cubed over 3x. Same thing. Boy, it looks a little bit neater though, going this direction rather than that direction. Doesn't really matter, however you want to go about it. Questions on number 11? Anybody? Okay. Let's try one more, and then I'm going to stop. Let's do one with an exponent. Oh, these all have exponents, but let's do one with a power rule. Let's try this one. 3x, this is 17, times 2x cubed over 4x to the fourth times 4x squared. And I'm going to raise that to the negative second power. So you have a couple options. You could apply that negative. Actually, I'll wait for you to write it down if you want to. This is number 17. All right, so you could give this exponent to each and every one of these things. So remember, we multiply exponents. The other possibility is you simplify the stuff on the inside first and then apply the exponent. I think that's my preference. So I think I'm going to cancel my 2 and my 4. Took care of my numbers now. Up top, I have a total of 4 x's, so I end up with 3x to the fourth. And down below, I have 4 times 2 is 8. And I have 4 x's and 2 x's gives me 6 x's. Now that's all still in this negative exponent, but I'm not done simplifying. 4 minus 6 is 2, and I got more down in the bottom, so I'm going to have that of 3 over 8 x squared. And now I can raise it to the negative second power. Questions on how I got to here? What I did in this mess to get to here. Okay, it's real important that you show me those steps, so then that way I can try to problem solve where you're losing it there, because there are so many areas that you can lose it. So make sure you show me your steps. All right, so this is saying 3 to the negative second power. Well, this negative on the outside of everything just basically means everything's going to flip and it's going to go to the opposite spot. So I think that's how I'm going to handle that. I'm going to deal with the negative first, because 3 to the negative second power basically, or negative first power, sends it to the bottom. 8 to the negative first power sends it to the top. And now I can deal with my square. 8 squared, 64. X squared squared is x to the fourth. 3 squared is 9. And that would be it. Questions on that one? Now, I chose 2 of the gnarliest looking problems to give you and to do for you. So the other ones that you have there aren't nearly that intense. Anybody have any questions?